If an event A can be conditioned on mutually exclusive events B1, B2, and so on, where exactly one BI must occur, then the law of total probability tells us the probability of A is going to be the sum of the products of the conditional probabilities times the probability of the condition. In some cases, there are an infinite number of cases to consider, so we'll need to sum an infinite series. For example, suppose we know that the number of accidents on any day has a Poisson distribution with mean 5, and the probability an accident causes more than 500 in damage is 0.25, independent of the other accidents that occurred that day. Let's find the probability that no accidents caused more than $500 in damage. So remember, concrete doesn't hurt. Let A be the event that no accident on a given day causes more than 500 in damage. Suppose there are n equals 3 accidents. The probability that none of these caused more than 500 in damage is going to be the complement 0.75 cubed. And so the probability that there are no accidents, given that there are 3 accidents, is 0.75 cubed. And since the number of accidents is Poisson distributed with mean lambda equal to 5, we have the probability that there are 3 accidents will be. So now suppose there's k accidents. Then the probability that there are no accidents, given that there are k accidents, is 0.75 to the k. The probability there are k accidents is our Poisson computation. And so the probability that there are no accidents causing more than 500 in damage is the sum of the conditional probabilities times the probability of the condition, which we can simplify to sum the series, note that the power series for e to the x is. So if we substitute in 0.75 times 5, we get. And so our probability will be. Or suppose we begin with an infinitely large supply of 6-sided dice. We roll a die, and if you get a 1 through a 5, set it aside. If you get a 6, you roll all the dice that you have, including the one that rolled a 6. What's the probability of getting at least 1 6 when rolling all the dice? Note that if you roll n equals k dice, the probability of getting at least 1 6 is going to be. And the probability that you accumulate k dice is a geometric probability, and so that will be. And so by the law of total probability, the probability of getting at least 1 6 is the sum of the conditional probabilities times the probability of the condition. So simplifying our sum, we'll factor out a 1 6, then we'll split the summation. And remember, the sum of a geometric series is the first term divided by 1 minus the common ratio. And so for this first series, the first term, when k equals 1, is going to be 1, and the common ratio is 5 6, and so that series will be. For our second series, we'll do a little simplification so we can make our common ratio easier to identify. We'll factor out a 5 6. We'll factor out a k minus 1 power, and that gives us. And so our first term, k equals 1, is going to be 1. The common ratio is 25/36, and the sum will be. Then substituting these back into our formula gives us 6/11.